Welcome, sixth graders, to our Unit 9 probability unit. Hopefully we can come back to school and still work on our probability carnival project. But you know, this unit is all about probability, um, and we'll be learning how all this stuff works. So we would have had to go through this unit before we could do our project anyway. So hopefully, like I said, we'll be able to come back together and still work on some of this stuff. Account for all possibilities. All right, so probability is kind of the idea of, what are the chances that something happens, right? What are the chances that you can pick something to happen? So in this case, a baseball team has four pitchers and three catchers. How many different pitcher-catcher combinations are possible? So this word here, combinations, that's a pretty common word to hear when talking about probability. One way to solve this problem is to make a list like the one started below. It says finish the list. So basically we have four pitchers and three catchers. So what we have to do is say, okay, so we have pitcher one and catcher one, pitcher one and catcher two. We could also have pitcher one and catcher three, because there are three catchers. And we got to go through this process for all of our pitchers and all of our catchers. So over here we have pitcher two and catcher three. And then we're going to do pitcher three, catcher one, pitcher three, catcher two, pitcher three, catcher three, pitcher four, catcher one, pitcher four, catcher two, pitcher four, catcher three. So this is a good way to kind of write it out, come up with a plan. Notice how we did all the pitcher ones first, then twos, then pitcher three, then pitcher four. Just to make sure we didn't miss anybody, okay? Then what we can do is say, okay, we have three of those, three of those, three of those, and three of those. So together, if we count them all up, that would be 12. Another way to get to that, which is kind of cool, is okay. So we have four pitchers and three catchers, right? Well, what's another way to get to 12? 4 times 3 is 12. So if we were ever asked, like, hey, how many ways could you do this? Well, you just take your total number of both events, right? It's called an event. It's an event to pick a pitcher, and it's an event to pick a catcher. So you have four pitchers and three catchers, so a total of 12 possible outcomes. So that's kind of what we're doing here with probability. Number 2, it says the baseball team has 2 first basemen, 3 second basemen, and 2 third basemen. How many combinations of the 3 positions are possible? Again, we can kind of do this in a way where we have 2 first basemen, 3 second basemen, and 2 third basemen. Okay, that'd be 2 times 3 is 6, times 2 more is 12. So we'd have 12 possible combinations to figure that out as well. A quarter is tossed 3 times. In how many different orders can heads and tails be tossed? So this is an interesting question here. Again, a quarter is tossed 3 times. So sometimes a little tree diagram is helpful. So first of all, I'm gonna flip 1 quarter. I'm gonna get either a head. Whoops. I'm gonna get either a heads or a tails. Then I'm gonna flip my second coin. I'm gonna get a head or a tails. And now remember, I'm gonna flip a third coin. I'm gonna do a head or a tails. Okay. So this is like the first flip. This is the second flip. This is the third flip. Okay? Again, each time, if we just follow it down, like, so this is 1 coin. I either get head or tails. Then this is my next coin. I either get head or tails. Then this is my next coin. I either get head or tails. So you're not flipping this many coins, but these are the outcomes that can happen. Again, how many different things could happen in the first row? That'd be 2. How many different things could happen in the second one? Again, a head or a tails, that's 2. And how many in the third one? A head or a tails, that's 3. So really what we can do we can do 2 times 2 times 2, which is 8. And if we look right here, there are 8 possible things. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so again, that just shows us that the idea works. Sometimes it's hard to think about, though. It's not 2 times 3, right? It's 2 times 2 times 2. It's more like exponents. Like you could say 2 to the third power equals 8, right? It's not 2 times 3. It's 2 times 2 times 2. So here a quarter is tossed 4 times. So again, that's not going to be 8. That's going to be 2 to the fourth power, which is 2 times 2 times 2 times 2, which is 16. Okay, so you got to just remember, we're not just taking 2 times how many times you're doing it. It's how many outcomes can happen. Every time you flip a coin, there's 2 outcomes. So that's what you have to remember, and that's what's kind of challenging about probability. All right, so we're going to let you go ahead and finish that page. We're doing pages 1, 2, 3, and 4. So looking at page 2 here, it says draw a tree diagram of all the possible gut-wrencher sundaes. So again, I'm going to do some abbreviations. My very first thing in the sundae is choosing what ice cream. So I'm going to do Whopping walnut. And again, I'm going to do some abbreviations here because I don't have a ton of room. So I'm going to do Whopping walnut. I'm going to do chocolate crash, and I'm going to do raisin rub out. Okay? Then I have to choose between coffee beans and anchovies. So I'm going to do 2, and I'm going to do coffee bean and anchovy. Coffee bean and anchovy. Coffee bean and anchovy. And then I can choose vinegar, honey, or Cajun sauce. This is kind of a weird sundae. But I'm going to do 1, 2, 3. Vinegar, honey, and Cajun sauce. 1, 2, 3. Vinegar, honey, Cajun. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. They're all going to be the same. Vinegar, honey, Cajun. Vinegar, honey, Cajun. So right now the big question is, how many possible sundaes are there? Well, we can do this with the tree diagram and count it, or we can do it mathematically. So what we do is we count the very bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 possible sundaes. Again, what's another way to do that? Well, we have 3 here, 2 here, and 3 here. So guess what? We can do 3 times 2 times 3. 3 times 2 is 6, times 3 is 18. So that's another way. That's kind of how we can get to it mathematically. And then sometimes, though, it's helpful to see it all written out. So again, more than one way to do things, just like usual. So you're going to go ahead and keep going through this. Again, looking at just an example, number 4, fire and ice. You get 4 ice creams, 4 nuts, and 3 pepper sauces. It says use the counting principle. So that's what I'm showing you, is to do it mathematically. So if we do that one, it's going to be 4 times 4 times 3. Okay, which 4 times 4 is 16. Times 3 is going to give us 48. So there's going to be 48 total outcomes for this fire and ice type setup here. All right. And again, this is page 2. So we've got some more things to look at here. Page 3, again, another big example of how to do this. Then, if we know the total outcomes, now we're starting to get into probability. So this says, what is the probability of banana, lemon? So looking up here at this example, there's 8 total outcomes. So what is the probability that you get a banana and a lemon? Well, that's only one choice out of all 8. Banana and lemon is only one choice out of 8. So what is the probability? Well, probabilities are written as fractions and sometimes percent. So we got 1 out of 8. So now it says, what is the probability of banana, vanilla, or orange, lemon. Banana, vanilla, or orange, lemon. So we got banana, vanilla, or orange, lemon. Now that's two choices. That's two choices because it says or. So you could get either like, what if this was a good flavor and this is a good flavor? So what is the chances you get that randomly? Well, that's two choices. Two choices out of 8. Or you can reduce it to 1 out of 4. Or as a percentage, that would be 25%. So these here would be your your probabilities. Your probability would be 1 out of 4. You have a 1 out of 4 chance to get banana, vanilla, or orange and lemon. Okay? Moving on to page 4 here. Again, you're going to continue practicing probabilities and the counting principle and making your tree diagrams and things like that. So if you have any questions, shoot me an email, let me know. Thanks. Have a good day.